Okay, and the next section has to do with evaluating expressions with rational numbers. Basically, it's plugging numbers in for a variable. So they will give you an expression, something like n minus 11/16, and they will say for n, we want it to equal a negative 1/3. So every time I see an n, I plug in negative 1/3. Here's an n. Negative 1/3 minus 11/16. What you'll notice is we have a negative here and we have a negative here. It doesn't become a positive because they aren't multiplying or dividing each other. What they're doing is they are combining. So whenever we have two negatives that are combining, they're getting pushed together, that gives us a bigger negative. We'll notice that we don't have common denominators, and so we need to be able to get them into common denominators. Once again, I want to take my biggest number, so 16, and do multiples of that until I get a number that 3 will go into. So 3 won't go into 16, 3 won't go into 32, which is the next number. 3 will go into 48. If you guys are wondering how I did that, a trick with 3 to know if 3 will go into a number is you just add the digits together. So 1 and 6 make 7. 7 is not divisible by 3. 3 and 2 make 5. So that doesn't work. That's why 33 works, is because when you add them together, it gets 6. And 3 will go into 6, right? So 33 is divisible, but that's not the number that we're using. And then 4 and 8, when we add 4 and 8 together, we get 12. Well, 12 is divisible by 3, meaning 3 will go into 12. So I know that 48 is a multiple of 3. Hopefully that made sense. Sorry if it didn't, but you guys will use your calculator a lot with it anyway. Just a little trick if you understood that. Okay, so I know that my denominator has to be 48. So I times 16 by 3, 1, 2, 3, that's how I got there. And I would times 3 by 16, because obviously if I'm timesing 16 by 3, I know I would have to times 3 by 16. So I want to do the same thing to the top numbers. Now, the top one of 16 I was timesing by 3, so I'll also times that one by 3. The top one of 3 I was timesing by 16, so I'll times that one by 16. So my numbers that I am now working with are 1 times 16 is 16, 3 times 16 is 48, figured it out over here. It's still a negative, and I am minusing 11 times 3, which is 33, and 16 times 3, which is 48. So what I have now is common denominators, which I needed, and so I know my answer is going to be that 48. I have on top, negative 16 minus 33. I am bringing two negatives together. I personally like to think of it as money. If I owe somebody $16 and I borrow $33 more, I owe them more money. So I would combine that. I would really get 16 plus 33, which is 49, and I'm still owing it, so it's still negative. Some people like to think of it as that number line. If ever you're going, so you would start at negative 16 because that's your first number. If ever you're subtracting, you're going to the left. If ever you're adding, you're going to the right. And you'll notice we are subtracting 33 more numbers. So we are going to get really far into the negatives all the way to negative 49. That's another way to think of it. I'm sure there's more out there. So you're welcome to think of it however you would like, as long as it works all the time. Now, this is my answer. I have a negative 49 over 48. I can leave it like this. I also can see, because my top number is bigger, I can take out one whole, right? Because 48 is the number of pieces that I need to make a whole, and I have 49 of them. So if I took out 48 of those pieces and say, all right, I have my one whole here, I still have one piece out of 48 to make another whole. And then my whole answer is negative, so then I would do negative 1 and 1 over 48. Either way is correct. It depends on what it asks for, how you would want to put that, but really they mean the same thing. So I don't particularly care which way it's given to me, as long as you understand the concept behind it. All right. I'm going to have you guys do an example of this, just where you're substituting and then solving. And then I think we only have one more section. So yay, yes.